we now show that this rate of return that we have called average internal rate of return is indeed an average, is indeed a mean. Then we delve into details of this mean. Now, to this end, we get back to the example we proposed. The 2-period project with 3 dates, time 0, time 1, and time 2. 2 incomes generated by the project at the end of the first period, 375, and at the end of the second period, 225. These incomes are generated by the capitals, 600 at the beginning of the first period and $400 which are invested at the beginning of the second period. Now, it is clear that we have 2 periods, 2 incomes, and 2 rates of return referred to single periods. In the first period, the project generates a rate of return, let's call it I of 1, equal to the ratio of 375 to $600, return divided by capital. And this is equal to 62.5%. In the second period, the rate of return, the holding period rate, is equal to the ratio of the income generated, 225, to the 400 capital that remains invested. And this makes 56.3%. Now, the project rate of return, the AIRR, is simply the weighted mean of these 1-period rates, where the weights are the capital. The weights of the mean are the capitals invested. So just let us make the computation. Now, the total capital invested in the project is given by the sum of the capitals invested. Now, given that the invested capitals differ by 1 period, we have to compute the present values of the capitals. So we sum 600 and the present value of the second capital that remains invested in the project. We remember that the cost of capital is 15%, and we get the total capital invested. The total capital invested is 947.8. Now we can compute the mean of the 2 holding period rates. The mean of I1 and I2 with the weight, we denote it by W1, W2. Now, how can we compute these weights? How do we compute the weights? The first weight is simply 600 divided by the total capital, 947.8, and this makes 63.3%. and the second weight is the present value of 400 divided by the total capital, 947.8, and this makes 36.7%. So we have the weight and we have the rates of return. 62.5% is the first rate of return, 56.3% is the second rate of return. We just have to multiply the weight by the respective rate of return and then sum. Let's make it. So the rate of return of the project, average internal rate of return, is 62.5% multiplied by the weight, 63.3%, plus the second rate of return, the second period rate of return, which is 56.3%, times the weight, 36.7%. So this is first rate, first holding period rate. This is the second holding period rate, and we have multiplied it by the weight. This is the first weight, weight 1, and this is the second weight, weight 2. The result is exactly what we have obtained in the previous video. The rate of return of the project is 60.2%. More generally, when we deal with an end period project, we can write that the rate of return of the project, the AIRR, is equal to the N holding period rate multiplied by the respective weight. The last summand is the last holding period rate multiplied by the last weight. The weight are measured as follows. The first weight is capital invested at the beginning of the first period divided by the total capital invested. The total capital invested is the present value of all the capitals invested in various periods. So C0 plus C1 discounted by one period plus C2 discounted by 2 periods, and so on, until the last capital invested at the beginning of the last period, C of n-1, discounted by n-1 period. We can also denote this total capital with the symbol PV, present value of the capital. And this is the first weight. Now, the second weight is the present value of the second capital invested. So C1 discounted by one period divided by total capital, and we can use the new symbol present value of all the capitals. And the third weight, similar, third weight is the second capital invested discounted by 2 periods divided by the total capital invested. And so on until the last weight, Wn, which is the last capital invested, C of n minus 1, discounted by n minus 1 period, which is divided by total capital. We have shown that the rate of return of a project, the average internal rate of return, may be calculated into two different ways. The first way is to compute the ratio of total return to total capital. Total return to total capital. And now, if we denote by I the income or profit generated by the project, the numerator is I of 1, the income generated in the first period, plus the discounted value of the second income. The discount rate is the cost of capital, which we denote as R, plus the third income discounted by 2 periods, and so on until the last income is generated at time n. I of n is the last income, which is discounted by n minus 1 periods. The denominator is the total capital. The first capital invested is the capital invested at time 0, the beginning of the first period. Then we sum the second capital, which is C of 1, invested at time 1, at the beginning of the second period, and we discount it back by 1 period. The third period is C of 2, capital invested at time 2. This is discounted by 2 periods, and so on until the last capital C of n minus 1 is discounted by n minus 1 periods. This is the first framing for the average internal rate of return. Then we have shown that the average internal rate of return can also be computed as a weighted mean. Of the holding period rates. Which we denote as I1, I2, and so on, where the weights are given by the capitals invested. So we have that the AIR is equal to W1 multiplied by I1 plus W2 multiplied by I2, and so on until the last one. And the weight at time t is given by the present value of capital C of t minus 1, which
which is the capital invested in the 10th period, discounted by T minus 1 periods. So this is the present value. This is the present value, PV, of the capital invested in the 10th period. We can denote it this way. And the denominator is the total capital invested. Total capital invested is this one. The sum of the present value, and we may denote it as PV of C. So we have PV of C. So we can write weight W of T is equal to present value of capital C of T minus 1 divided by the total capital, which is PV of C. So we have seen that we can write the AIRR as C0, which is the present value of C0, it's the same, divided by PV of C, multiplied by the first holding period rate, plus the present value of C1, divided by the present value of total capital, multiplied by the second holding period rate, and so on until the last one, which is the present value of C of n minus 1 divided by the total capital, PV of C, which multiplies the last holding period rate.
I am breathing life into my own life. I am breathing life into my own life. I am stealing time, borrowing time from my own time, 'cause it seems so full of itself, so selfish at times, like